All right, it is 11:30, and since UN, who's our first presenter, has to catch a flight, we're going to get started right on time, also because we have a very full agenda.
You
So-
need to speak closer to the mic.
I need to be closer to the mic. All right, is this mic actually on?
Yes.
Good, all right, great. So yes, so this is the AVTCORE session, IETF 124, welcome everybody. Starting off, of course, the note well, by being here, you are participating in the IETF. By participating in the IETF, you have agreed to follow IETF processes and policies. This is a reminder of a bunch of those, notably the Code of Conduct and Anti-Harassment Policy, the IPR policy, the standards processes, and the privacy statement. So please make sure you're aware of all of those. And there's a nice QR code here on the screen that has links to the details of all of those so that you can find more information if you need it. If you need any advice, talk to the working group chairs or area directors. Please make sure you know that. And this is the new version of the note well. I believe all the policies are the same, but the wording on the slide to tell you about them is clearer. So, all right, meeting tips. Please make sure to sign in to the session, either via the data tracker or the QR codes, which are various places around the room, I think. Use the meeting, you probably want to use Medico Lite if you're in the room, but you can use Medico Full if you want to see video and screen shares. Slides will show up in the light, but not screen shares. Please, if you are on site, please make sure, especially to mute your audio playback, or we'll get bad echo in the room. If you're remote, please keep audio and video off unless you are presenting or chairing or speaking, and use of a headset is strongly recommended because echo cancellation isn't always perfect. And everybody, please state your name each time you begin speaking. I'm Jonathan Lennox, by the way, if I didn't say that. My co-chair is Marius Kleidel, who is remote today. All right, here's some resources, some links, sort of general for everything related to IETF. Okay, our agenda today. Starting off with these preliminaries, and we'll be doing the revived RTP for S-frame, for SDPR for answer for quick, JPEG XS, avatar representation, Opus multi-stream, and RTP frame acknowledgement. Anybody have any agenda bashes? Otherwise, we'll move on. It's a pretty tight agenda, so I'm going to try to be fairly strict about time. And our draft status, we have published RFC 9828. We have one draft of the IESG, two drafts that had working group last call. For haptics, we have a Shepherd write-up in progress. And RTP over quick, we don't really have enough responses. So even though formally we've completed working group last call, we really please do read and comment on that draft so we can get to enough point where we can decide whether we're ready to go to send it to the IESG or whether it needs revisions. We've newly adopted 3 new drafts, SDP Rock, which we're talking about today, JPEG XS, and VDMC. We have a number of things that we have adopted. I'm probably going to need to try to encourage HEVC WebRTC, the new editor, to get moving on to that. And we're going to call for adoption on ABV. And maybe we'll have more adoption decides today. All right, that is it. So UN, you said you, let's see, so stop slides. Where are these controls? Here we are, share slides.
Can you hear me?
S-frame. And I can, do you want me to drive, or do you want me to share, send to you the slides?
Yeah, you can drive, that's fine.
Okay.
I'm hoping everybody is hearing me in the room.
We do.
Okay, perfect. Yeah, so I'd like to talk about S-frame RTP packetization. Next slide. So we have a bunch of people, Harald, Richard, Peter, Jonathan, and I. We met and we wanted to move forward with the draft from Peter from 1 or 2 years ago. And one important goal is to support both per packet S-frame and per frame S-frame. Per packet S-frame is used in products like WebEx, and per frame S-frame is the model that is sort of supported in browsers and used in products like Web FaceTime and probably other web application-based video conferencing tools. And yeah, we really want to bridge the gap between the two modes and let applications decide what they want to use. So at the packet level, it requires the ability to split a S-frame payload across several RTP packets, because the S-frame payload may be of arbitrary length. So you can see the on the slide, on the right side of the slide, a typical RTP packet, and there's S-frame payload, and there's 1 byte at the beginning, which is where we are adding the information that allows to split the S-frame payload in several RTP packets. So there's a start bit, there's an end bit, and the depacketizer will be able to recombine several RTP packets that belong to the same S-frame payload so that it can concatenate the payloads and then decrypt the content. So that gives the appropriate granularity and the flexibility that we need for per frame or per packet. Other than that, it's nothing special. Next slide. So we also added how the SDP negotiation is supposed to happen. So we decided to go with the M section level. So you can decide to negotiate S-frame for a whole M section, which means that so the S-frame packetization is used for all media encodings. So in the example, for instance, the first one, the audio M section, you can use Opus or CN, but both will be packetized by the S-frame packetizer, and they're supposed to be encrypted. So S-frame negotiation currently is limited to let's use S-frame or let's not use S-frame, that's all. There's no S-frame option that can be negotiated currently. For instance, there's not the notion of being able to say, hey, I want per packet or per frame S-frame. It's the smallest negotiation that we can get, and we think that it should be good enough, and that if we need to, we can extend support later on. So by having the S-frame negotiation at the M section level, the good thing is that you can mix S-frame and non-S-frame in a single SDP. So if you want to keep the ability to send encrypted and non-encrypted end-to-end content, then you can, for instance, have 2 M sections, one that will enable S-frame and the other that will not. Next slide. I think the third and final change to the spec was that in the past version of the spec, where in the RTP payload, we were adding the media payload type, meaning the media type of the payload after decryption. And we decided to remove this as it is a simplification, and especially switching S-frame on a per packet basis, it doesn't seem needed in our use cases, and also it's a minor network gain anyway. So yeah, again, if you're starting to mix in a single SDP S-frame and non-S-frame content, the thing is that you need different payload types for the same media encoding should you use S-frame or not. That allows to have unambiguous information of both the media encoding and whether S-frame is in use. This is a small potential downside, but we think it's fine as is. Yeah, next slide. So that's that. Yeah.
No, okay. Okay, go ahead.
So that should give an update on the current draft of the spec. In parallel to that, we had discussions within WFC working group whether this model that I exposed was fitting well into into existing web APIs, especially WebRTC and Coded Transform. So we discussed that at the last meeting, WebRTC interim. And overall, I would say that there was rough consensus that the model was okay. So for instance, the web application should be responsible to tell, hey, I want S-frame, or I do not want S-frame. And it should also tell to the user agent, hey, I want per packet or per frame flavor of S-frame. And user agent, you need to implement, you need to use the correct version that I'm asking you. So other things like key material and so on, they're already, the web application is already responsible for that, and there's already an API for that. So we think that with modest changes to the web APIs, we can integrate well this S-frame RTP packagization. During the meeting, we discussed how S-frame should be enabled or disabled, whether we should handle the ability to renegotiate S-frame, basically. Let's say that you have an section, it does not, so S-frame is not enabled. Should you be able to enable it on the fly using a renegotiation? So currently the proposal is that it's not feasible. So basically it's when you create the transceiver, the equivalent of the M section, that you need to decide whether S-frame will be activated or not. And then it's fixed for the lifetime of the M section. Should you need to enable or disable it, then you would need to create a new M section, basically. So that seems a good trade-off to me, because it's a good simplification. And we're starting very strict, and we can always relax later. So in terms of web APIs, that would mean that we would throw or reject initially. And then web applications, if they discover that we no longer reject, it means that somehow we relaxed and so on, and they can adapt to it. So it seems forward extensible as well there. Next slide. So most of the use cases that we heard and we had in the past were either video conferencing without S-frame or video conferencing with S-frame. But this mix and match, where you would have like the possibility to either upgrade or downgrade to S-frame. So this use case was mentioned, and the current solution is to use 2M sections at the start and per potential media stream that you want to send or receive. And then it's up to the web application to enable sending and receiving on the particular M section that is used for. So this doubles the payload types, which seems okay so far. So next slide. So we have some open issues. So the interaction between RTX and FAC and S-frame packetization. We hope it's transparent there. So the principle is that S-frame encrypted packets are sent. So that would mean that RTX, for instance, will retransmit S-frame encrypted packets. So it should be business as usual. We've read an S-frame The current principle in the spec is to stuff several S-frame payloads into one single read packet. The alternative would be to S-frame the read content itself. But so far that's what we have, and well, should be good enough as well. There's the possibility to add additional SDP flexibility. So for instance, should we add an A equal S-frame at session level? So far it does not, and we'll probably leave it as this, except if there's interest. There's also whether we should allow more S-frame parameters like per packet or per frame in the SDP, or the quickest suite to use there. But so far there's no support, and we'll keep it like this, except if we are hearing feedback about that. And also we need to finalize the things about the SDP negotiation rules that will be further restricted in WFC WebRTC encoded transform spec. So is the WFC spec the right place, or should it be in AVTCORE? I tend to think that it's good in WebRTC encoded transform spec, but I'm also interested in hearing about feedback there. And the last slide is next steps. So we need to address comments, answer questions, and open issues. That will give a draft that we hope is almost complete. We got the feedback that it would be interesting to have per SSRC key derivation guidelines. So either M section or SSRC. So this draft could be used there. So it would be guidelines, not mandatory. So it's an open issue. We need to figure this out. We also want to fully validate the interaction with WFC specs. So we need to update the WFC specs and verify that everything is matching, and get some implementation experience. So hopefully there will be some in the year to come. So we're hoping to, in the next year or so, to do all of this. And hopefully maybe in a year or so, we will finalize the draft at that point. And that's it for the slide.
Niels?
I see Niels on the queue.
Niels Omer. Question on the on the SDP signaling. So you're saying like A equal S frame. What happens if the answerer basically doesn't reply with that? I'm guessing that means like I'm not supported or I'm not willing to do it. But then can the offerer basically say like I'm only willing to do this video track, for example, if you agree to do S frame, kind of like it's required or something like that?
Yes, it's required, meaning that if the answerer is saying, "Hey, I don't know S frame," basically, because that's probably what will happen in practice, then the offerer is supposed to stop the transceiver when applying the remote description.
But then you get an answer without the A equal S frame.
Yeah.
But like the answer is not rejecting it. It just says like, hey, like I'm going to RGP without S frame. So then the offerer needs to offer again and say like I'm now rejecting this M line in a subsequent offer answer.
So the offerer will stop the M section, and yeah, I guess there will be a need for another negotiation. Yeah.
Just not send it. Okay. And another question was, I think you said like there's no way to signal whether you're using per packet S frames or per frame, but then you later mentioned that for the browser, the application should actually be able to get that information. Would that basically be like you would have to wait for the first packet to come in, or can actually
It's not getting the information, it's setting the information. So basically,
it only sets it's what it wants to do, but like and then
so the application will say, hey, I want to use an S frame transform, and by the way, this S frame transform is per packet. There's a per packet option or per frame option.
Okay, and but implementations would need to support both because it's not signaled.
The user agent, yeah.
So like theoretically also one side could do per packet and the other one could do per frame?
Yep, and it will break.
Okay.
Yeah.
All right.
But I mean, it's no different than trying to send S-frame content and not having the right keys. Everything will break basically. So.
Yep. Okay.
Gurteej from Apple. Hey, Yuan. So just extension of that question, besides just whether per packet per frame, there's also cipher suites and like different cipher suites that you might want to use for different M lines, like for audio and video, we might want to use something different. So, and that I didn't see that in the SDP also. Is there a provision to exchange that in the SDP, or is that also expected to be negotiated out of band? And now it can be different per M line. So in effect, you're doing like an out of band negotiation outside of the SDP in the application layer.
Yeah, currently it's out of band. And so one reason, so basically when you're setting the S-frame transform and you're saying, hey, I want per packet or per frame, you will also say, hey, by the way, I'm using this crypto suite and I'm using these keys. And one reason we currently do not have these options in the SDP is that typically you have the sender, the SFU, and the receiver. And the SFU does not need to actually know the crypto suite or to know whether it's per packet or per frame. So it's okay to not have this information in the SDP.
Okay, thank you.
Magnus Westlund. I want to follow up on that because I have the same, I mean, especially if you're using different tag lengths. Don't you need to know which payload format contains which type of S-frames? Which cipher was used?
So basically, the transport in browsers, the transform is per M section. So for a given M section, you will need to have a single crypto suite that is in use at any given time. And should you want to change the crypto suite dynamically, you can do that by the out of band mechanism without renegotiating, and that should be fine too.
Yeah, although I don't have any, I think a general high-level question here is for everyone to think about this. With this, it's very deadlocked down to, I think, WebRTC, etc., and others that has assumed to have very strong out-of-band signaling mechanism on top of SDP or outside of SDP. I don't know if anyone plans to use it in others, and before we have tried to keep certain generality, but yeah. So.
Yeah, that's a very good point. The idea is really to keep it as simple as possible to the current use case, but still knowing that we can extend it in the future. We don't want to add options that might be not used in the current deployment scope that we have. And should somebody has a use case, I think we will be happy to extend or reconsider this and extensions.
All right, Jonathan, next speaking as individual, but since I'm driving the slides, staying at the chair desk. Yeah, I think this. I'm not close enough. All right, sorry. Yeah, so I think this needs to. I'm speaking as an individual. I think this needs to be clearer about what goes in inside the encrypted payloads. I mean, I think the idea is it's just the goal here is to make it essentially the same as the WebRTC encrypted transforms, which makes sense to me. But I think we need to be explicit that these are just effectively the raw frames, or possibly, yeah, and yeah, go ahead.
So there's a section with an algorithm, and for per packet, you go through the media-specific packetizer first, and then you encrypt the payload. While in the per frame flavor, you're right, it's the raw data. And I tried to, so in the spec, I tried to express the two scenarios, the two cases there, so that it's clear. But I would be glad to receive feedback on how to improve that and clarify.
Yeah, okay, yeah, that's. I mean, the tricky thing is I'm not sure you can tell the difference between somebody doing per packet versus somebody doing per frame when the frame happens to be less than an MTU. And if those are supposed to have different treatments on receive, that's a problem.
That's a web application that needs to tell the user agent to, in the browser territory, it will be the application that tells.
No, I mean on the receive side.
Yeah,
on the receive side.
On the receive side as well. Yeah. Receive
either that
side
or have
to know.
either that or you have 6 unused bits in the header right now. So maybe
maybe. That's a good point.
The other thing is we probably want to mention, at least advisory, is that in the per frame case, you don't have things like the all the various metadata that you usually have. So you probably want to have something like the AV1 dependency descriptor or the or the frame marking header extension.
Correct. There's a GitHub issue about this.
Okay.
And I agree. Yeah, I agree.
Richard, you were in queue, but then you dropped out. You're good? Okay. All right. In that case, I think we are, I don't see anything else in the queue, so I think we're good and we're right on time. So excellent.
Thank you. Bye-bye.
All right. Great. Thank you. Have a good luck catching your flight. All right. So I think next up is Spencer, who I think wanted to share the slides himself. So I think request slides, Spencer, and I can grant that. Yes, asked to share the screen. How do I answer that? There we are, grant screen. Now you have to say what screen you want to share.
Yes, okay, and is that working for y'all?
Yes.
Okay, looks like it is. Thank you, Jonathan. So I'm Spencer Dawkins, and representing myself and Victor as co-author this time. And thank you all for being here. I want to start by giving you all a little look behind the curtain in Slack. I told Mattis, I said I was going to do the PRs like a month ago, and there's nothing like a deadline to focus my attention. And Mattis just smiled. So I am just mentioning this because I think everyone involved, including the chairs, had wildlife events in the past since IETF 123, and that actually included Victor picking up a new child this summer. So they were not small changes, but deadlines are good. So maybe we can schedule an interim.
Yeah, I think probably the January timeframe makes sense.
Perfect. Thank you.
Yeah. So Marius, let's make a note for that to make sure.
And we'll try not to adopt any more kids or dogs. So the draft is in the GitHub repo. It has been renamed after adoption, and I did pick up an editorial correction from Hunsek. Thank you for that. And I started after IETF 123 with 2 open PRs. One I think is now ready to merge, and one needs more eyes. I'll talk about what that is. And of course, there's still a small number of open issues, and it would be good if we could work through those as well. So first up was a PR. It was PR 30, is now PR 34, clarifying the relationship between ice and rock. I had some really good discussion with Harold and with Roman. Thank you both for that. And so I made several clarifications based on that conversation, and I needed to rebase anyway. So this is now PR 34. It should look a lot like PR 30 if you've looked at that, but please review it. PR 29 really needed, I mean, it was just flat out wrong. So I was clarifying the relationship between bundle and rock flows. And in PR 29, there wasn't one. So after discussion at IETF 123 and with Mattis, we have convinced ourselves that the best thing for us to do at this time is to say, if it's an RTP session then it's a rock flow. And if it's a rock flow and you're doing SDP, that's where, that you put your bundle in one rock flow. There are other alternatives. They have loads of complications. Jonathan named several in previous discussions and said he had low confidence that he had thought of all the complications. So like if you have translating middle boxes and you have rock on one side that's not bundled and you're doing bundled RTP on the other side, that was a train wreck. So completely different PR number 35. Please review that. Picked up a new issue, number 31, during the adoption poll from Russ Finlayson, pointing out that the title is being SDP offer answer was basically defining declarative style SDP applications as being out of scope, and that was not intentional on my part, certainly. So I would like to just let the working group think about that. I can do that easily enough, but the one question I have is whether TLSID works this way. And that's the only thing that's mentioned in the SDP draft right now that would worry me. I can ask if people have thoughts now, or I can take questions later. Is anybody diving for the microphones?
No, it doesn't look like it.
Cool. I'll move on. So we're adopted. This is great. So what's left for AVTCORE to do? So we have an experimental rock specification. That specification survived working group last call the first time, but as the chair said, more feedback is needed. I said welcome in my slide and then looked at the chair slide, which said needed. We've tested interrupt for several implementations. The testing was performed using manual configuration, not using signaling. We've adopted an experimental SDP rock specification. We have a small number of open issues that we need to resolve. And I'm checking a note. So I had offers to review the document from Jonathan and from Gertag previously, and I had not asked for those reviews prior to adoption, but now that we're adopted, that might be a good thing to do. And review and issues from other participants is wildly welcome. Thank you for that. Years ago, like the first -00 of the individual draft, we said we're doing SDP for rock in AVTCORE because that's where the that's where the RTP and rock expertise is going to be. But M-Music is the one that actually is responsible for SDP. So we said we would ask for M-Music review on that. I don't have an opinion about when that happens.
M-Music is now officially closed, including its mailing list. So.
Oh, okay. So we're all here.
Yeah.
Perfect. Including the mailing list. Man, that is hard.
I believe the mailing list got closed. I'm not positive, but.
Well, that sounds like a deal to me.
Yeah.
So thinking about what's left to do in AVTCORE and what's left to do elsewhere. So starting with what's in AVTCORE, I'd like to converge on the proposed title change to allow declarative RTP applications to use this, like RTSP. I'd like to merge the ICE before rock PR, which I think people who've looked at this before like. The RTP session equals an RTP flow equals bundle PR, and that should actually be 35. sorry, PR number. And there's a related PR in 238 because the rock-based specification was not super clear on when it was talking about RTP sessions and when it was talking about RTP media flows. Harold?
Thanks for the great clarifications. Hello, John.
Hi.
One point that I'm sorry I didn't review your PR before the meeting.
It's been out there for like 2 days at a maximum. Don't feel
yes. So I couldn't have reviewed it before the meeting, but I could have reviewed it last night or something. But anyway, I think you still need to change the protocol to name a protocol specifier in the ICE candidate, because matching up a UDP candidate for a port that expects RTP packets and a UDP candidate for a port that expects quick is not going to make anyone happy. So I made that comment in the PR. Okay,
and thank you for that. That actually is a really good comment on the next slide. So I will mention that you said that when we get to the next slide. I've got a couple of issues out there that were not now. Basically, like one of them was, a question. Do we need to say anything about the use of rock with mask? Because one of them, I'm trying to remember what the other one is. But if we're getting to the relatively mature end of the specification work, which I either think or hope we are, it would be a good thing to actually triage those issues. And finally, converging on the first class transport direction, and I'd love to have this done by IETF 125, and we'll talk. Next slide. So we talked about this previously. Do we want to make rock a first class RTP transport? And I asked this the previous interim before 123, and Jonathan said no, and Harold said yes. So there's some debate about that. But I think more broadly than that, there is some debate about what it would mean to be a first-class transport. This could mean, as Harold said, ICE returns quick candidate pairs. This could mean update RTC web to include rock. This could mean update the web RTC API to include rock. This could mean update the web RTC API to include the quick feedback that a web RTC application might want to see. So there's a range from appetizer to dessert, a menu of possible things that we could do there, and I would love to talk about that. I would love to talk about the details in more detail at an interim. I would love to have at least a set of alternatives, and I mean this is a set of alternatives, but maybe not the right one. Before we try to spend a lot of time talking face to face, because I'd like to make sure that we are all talking about the same thing when we're talking. And we could do this as a design team. We could do this on the AVTCORE mailing list. I'm like I say, I'm curious what people's thoughts are here. And Jonathan?
Well, Harold's in the queue, so let's let him.
No, and I'm actually asking how I'm doing on time. This is my next to last slide.
Yeah, there's a time. You should see a timer. I think you have like 7 minutes.
Okay, yeah, okay. I was looking for a red one and it wasn't red yet. Hi,
It's not
Harold.
ready yet.
Hi again. So we don't need any update to the WebRTC API to just select rock. The WebRTC API has full control over which remote candidates it decides to inject into the connection.
That's good news.
Updating WebRTC to include our quick feedback, well, that's a whole different kettle of fish. I mean, there's a ton of stuff in RTP where people have suggested that we should just not use it and use RTP, use quick mechanisms instead. But that's not a small task.
Yeah, and like I say, I'm trying to just level set, making sure that I understand what we're doing there, and that's you're always super helpful, and you just did it again, Niels.
Niels Omeyer. I think I agree with what Harald suggested. Basically, I think the most straightforward path would be to define an ICE candidate which only gets paired with another rock ICE candidate. That gives like the WebRTC application the chance to either drop all other ICE candidates if it really wants to require rock only, or it can drop the rock candidates if it doesn't like to do rock. At least that would be easy for the transport part. What that means then for what kind of like RTP header extensions you want to negotiate if you require rock, I think that's a completely separate beast, basically. What kind of feedback and next TRECT and all of that good stuff.
Yeah. So what we said for the rock specification originally was that we needed implementation and even deployment experience to get a good idea of what kind of quick feedback it makes sense to use, and if there's something that we can't get from RTCP or from Quick, then that might say some things about work to happen in the Quick working group. So I guess my first question on this is the ICE working group open still?
No, that's gone.
Okay.
So I think we've sort of. I mean, Gory left, so I couldn't say for certain, but I'm pretty sure we've probably inherited all of this. So.
Okay. Good news. Good news.
Yeah, and I think Harold and I were talking a bit this week, and he may have convinced me that making rock a nice candidate is actually a doable and sensible thing. So.
Okay. Perfect.
It's a little bit of a layer violation, but not terrible, and probably easier than anything else.
Yeah, and I'm trying. I was certainly hoping to minimize the amount of confusion that Rock would be creating for people who are doing WebRTC at this point. So,
yeah, especially that seems to be the primary target case.
Cool. So that is super good. That is super good news, and I think I know what to do now. Just repeating my. Does this work? Yeah, that works. Cool. Just going back to this, making sure that we've identified the open issues for SDP Rock. And any work we need to do on SDP Rock, knowing about that sooner rather than later will be a good thing to do. So it sounds like that's a good thing to do. That asking people to consider implementing SDP Rock and doing their Rock interop testing with it would be a good thing to do, and starting work on a ICE rock candidate draft would be a good thing to do.
Yeah.
Does that sound about right?
Yeah, I don't know if it needs to be a separate draft so much, just probably maybe just a section in this, but you can think about that.
Yeah, when we got text, we can put it someplace.
Yep.
Cool. Okay, great. And thank you all. And I think I may be giving you 2 minutes back if nobody else is in queue.
Well, excellent.
Fabulous.
All right.
You've made my life. Thank you.
Excellent. Good. All right. And then, in which case, next up is Tim.
I hope you can hear me well.
Yep. Okay. This should be. Do you want me to give you slide control, or do you want me to drive this?
No, it's just a few slides, so you can. I will ask you to go next slide.
Great.
Thanks. So I'm Tim Brellans, working for IntoPix. Yes, yeah, you can go ahead. And it's this is a presentation about the RTP payload format for JPXS, which is currently already an RFC written for and published. It's 9134. And it's heavily used in broadcast and Pro AV industry by various specifications and organizations. I list here the most important ones, but there are many more companies that are actually relying on this RFC. Yes, next slide, please. And so with the RFC 9134, as it is today, it was published around October 2021 when first edition was of JPXS was already published and second edition was under publication. So we knew how it would look, and the RFC was ready in time for XS to be used. But in the meantime, there was some additions, like an amendment in part 2, and then everything got reworked in JPXS to have a third edition of the standard. And there we added some new coding tools like frame buffer-based temporal compression and additional mechanisms. Next slide, please. So I want to explain this because the standard of JPXS evolved a little bit, and while RFC 9134, we tried to write it in the past to be as independent as possible to the ISO standard, so to not rely too much on the internals. There are some places where this was unavoidable. And one of these places is that the RFC references the SLH marker, which is a 16-bit code in the code stream of JPXS, which marks or demarks the beginning of a slice, which is explained in the standard, but also in the RFC, by the way. And so when we introduced this new TDC, the temporal differential coding mode, with the associated profiles in the ISO standard, we needed to rely on a different marker, which is called the SLI marker, and it's also a 16-bit coder, but it's a slightly different value of code. And unfortunately, the RFC only mentions the SLH marker. And so technically for the RTP, it's very conceptually very simple to embed TDC code streams in the current RFC, but strictly speaking from an interoperability point, we should update the RFC to also mention the SLI marker and to be technically correct. While they are both 16-bit codes and functionally they serve the same purpose. But in addition, there's some other changes that are needed, or some extensions, let's say. So TDC also introduces a frame buffer bandwidth level parameter or concept like profile level and sublevel. And the FBP level does not exist in RFC 9134, so we would like to add a dedicated parameter for that to be able to support it in the SDP negotiation. And then also on the RFC, we got a lot of feedback from industry where implementers complained a little bit about kind of ambiguity in regarding the interlaced video signals. And so we noticed this because some interoperability issues arise, and this was due to the fact that the text was not always clearly written or formally enough written. So we would like to address that. And then finally, there was also an erratum submitted for the RFC. I submitted it, but it was, of course, also feedback from industry. So if we are updating the RFC, we would like to also implement this erratum, of course. Next slide, please. And so I prepared together with the original authors of RFC 9134, we prepared an updated document. We proposed to obsolete RFC 9134 because some of the changes, although everything is minor, they are in various places. And I think in order to keep the document readable, we propose that we obsolete RFC 9134 and just write a new RFC. But we made sure that it is 100% backwards compatible. So people that already implement the original RFC, they will still be compliant with the new RFC, just not supporting the TDC profile, and vice versa. If you implement the newly proposed draft that hopefully will become an RFC, then you automatically also are fully compatible with RFC 9134. And so I explained it here, existing senders remain compliant, so they can remain sending what they have been sending in the past, and existing receivers will still work for the old streams, so it's not an issue. And so we prepared a draft, and so it integrates the erratum. It added a lot of text to clarify the handling of interlace video signals, so this should be much clearer, and we also had feedback from companies in this respect, and I'm still collecting more feedback on the current text, so I think we are pretty good for this. And then the provisions needed for the TDC functionality were added, so the use of the SLI marker is now available in the text, and then extra SBP parameter for the FBB level is present. And then while we were at it, we took the opportunity to fix a lot of minor text issues or made improvements in the way the text is written, but functionally it should be similar or the same. And then we also improved the definition in the text of slices, because there will be an upcoming amendment 1 for JPXS part 1, which will be used by VESA organization, for example. And so we opted to already make sure that the current text is compatible with what we plan to do. I think this was the last slide already. So I prepared everything in the GitHub repository, and I was asked after the call for adoption, which was positive, to upload the text as the draft IETF AVTCORE thing, but the submission forum is closed due to the IETF meeting. So I was just a few days too late to do it. So I will do it after the IETF meeting.
Okay. I mean, you can do it now. As soon as the meeting starts, it's
Okay. I will do it tomorrow or today. Yes.
Okay, great. Thank you. I guess my one question procedurally is, are we formally referencing Amendment 1? Does that mean we have to wait for that to be published?
So no. What we did is the definition of slices was the way it is written. You can describe it in various ways, and we just made sure that the way we write it will be compatible with what the amendment will contain. The amendment is very small, by the way. It's already under ballot in ISO, so normally it will be approved in January of next year, but then it takes probably 5 months for ISO to publish it on their website and as an officially new amendment. So we cannot wait for that, because there's a lot of pressure from industry to have this TDC compliant RFC out as soon as possible.
Great. And as far as you know, there's no more open issues with this?
No. I made some minor text edits, so the IETF one will be the latest. Will be the updated version. Everything is tracked in the GitHub repository, and I will try to collect final comments from the companies that are involved.
Okay, great. So it sounds like we're ready to go to group last call for this already.
Yes.
So
yes.
Marius and I will schedule that as one of our
new
items. Great, thank you.
All right.
Just to clarify that, you don't want to wait more on the company and integration feedback?
Well, it's mostly companies like Matrox and Magnica. We have extremely close collaboration, and they already provided me with feedback which is in the text already, so it should be okay. So I will upload the IETF thing and immediately also send out an email for them to go and check if the changes they think were necessary are sufficient or okay. And I expect no extra comments, but you never know. I will ask them.
Yeah, I mean, it would be helpful to us if they also sent those comments to the AVT.
Yes, I will
list.
tell them. Yes.
Yeah, so we have confirmation that the people who are using this are happy with the.
Yes, I agree. That's good. Thanks.
And whether we want to make that part of working group last call or before working group last call doesn't really matter.
When does the last call when can it be issued?
We need to figure out our scheduling. Depends on what other things. But as far as I know, it could be soon. I mean, let's. Well, Mario will discuss this, but I think it could be soon.
Soon is like in a few weeks or so.
Yeah.
Okay, that's perfect. Okay, thanks.
Okay. Yeah.
Yep.
It sounds like
No
this
pressure.
is an easy one. Great.
All right. Thank you.
Thank you. All right. Let's see. So next up we have ARF. Let's see. Stop slides. Start slides. Here we are. Do you want me to do the slides, or do you want to use the clicker?
Try to use it.
Okay, let me see. I think I do this. Yes. That should work, I think. Yes, good.
Hello everyone. Today I'm going to present about the RTP pillar format for ARF animations. So this is the outline for today's. So first of all, I'd like to review the last IETF, and we received a few questions in the last IETF, and thanks for that. And I think that we addressed all of the comments back then, but we need a we have a little bit more updated information, so I'd like to clarify the answer again here. So first of all, we're asked for the data structures. So the avatar has the 5 types of the AAU: the configuration, plane shape, joint, landmark, and textures. And each AAU contained only the delta value of the position relative to the reference model. So for example, if we have the one avatar, which is composed of body and the face, in that case, AAU for the body, which is joint, and AAU for the face, which is plane shape, could be present. And regarding the data size, some of which would be larger than the typical MTU. And the next one is about data characteristics. So basically, the animation data use the delta value from the reference model. So the animation behave as if it used absolute value, absolute coordinate. So when some packet is lost in the middle, the animation may not look like the perfectly smooth, but it's still okay. And for next one is about the texture type. So as I mentioned before, the data use the delta value, so it doesn't include any texture images. So, and the texture will be downloaded separately before the communication start. The last one is about the scope of this draft. So in the MPEG specification, it defines some procedure how to download the template, avatar template, but we are not considering that the process in this draft. And we have a little bit update in our draft. So first of all, we revised the abstract to define scope clearly based on the latest MPEG specifications. And we also added one more AAU type because the specification is updated. So we add the texture AAU, and we also update a little bit optional parameter because the latest version of the MPEG specification just changed the name and delete some part and add one more value there. And we also a little bit added more explanation to understand more about the parameters. So suggestion and the feedback are always welcome. And I think the MPEG specification of the avatar is going to in the middle of the DI stage, so that will be finished around January. So I think this is a good time to request working with additional code. So thank you.
All right. I mean, that seems like it certainly sounds like this fits within the scope. Does anybody have any comments or anything? Or otherwise, I mean, if we can do an adoption call and we can see. I mean, I assume you can. You know, people who are interested in using it can let us know that they want it, and if we have enough interest that people want this, then we can go ahead and adopt it.
Okay, thank you.
Great. So let's see. I can take the slides back, turn off the slides, and next up we have Sun. So Opus Multistream. Sun, do you want me to hand you the slide control, or do you want me to drive the slides?
Yes, please.
Well, sorry. Yes, please. To which?
Hand it for me.
Okay, I will. So hand it to you. All right.
No. Could you control the slide for me?
I will control the slides. Okay, sure.
Okay. Yeah. Just thank you for giving me the opportunity. My name is Sunshin, and I'm from NVIDIA. We are working on cloud gaming service through the browser. So next slide, please. Yeah, I'm going to present proposal for supporting the Opus multi-stream. As a quick introduction, multi-opus can be used for various scenarios, but I think we are more interested in providing the cloud gaming service because there are many contents has multi-channel audio, surround sound like 7.1, 5.1. So we have already has lots of content and we want to provide that surround sound through the web. Next slide. So what is the current issues problem and what is the proposal we have? As of today, libWebRTC already has integrated multi-opus support as a basic functionality. But there are some APIs like create answer, create offer that doesn't support multi-opus because of lack of formal standard. So there are two related standard at this moment. One is RFC 7587, which define the RTP payload format. There is another one, RFC 7845, that is about multi-stream opus. But there are no current existing spec to link in between. So this proposal is to get this SDP syntax as a standard. Next slide, please. So this goal is to have this syntax more explicitly, how to define multi-opus like as a SDP syntax, multi-opus and channel count and format parameters. We can use a number of stream, coupled stream, and channel mapping for mapping the each different channel of speakers on the device. Also, we would like to propose that create an answer and offer. We can use the multi-opus as a standard. That is the basic idea of this proposal. Next slide. Yeah, I think that's it. Well, I want to hear some feedback, questions from the audience.
See Nils and Jean-Marc. Jean-Marc, okay, you should get in the, are you in the, you should use the slide. I mean, yeah, go ahead, Nils.
Niels Omeyer. Just to clarify, I mean, totally okay and good idea to standardize this. But on your slides, you said that basically standardizing the SDP parts, then you no longer need to do the SDP munging. That is a completely separate issue you would have to take on with the W3C, right? So like only because you have to have it in the SDP standardized, then like the browsers can implement like support for it on the SDP level, but it doesn't mean that you actually have an API in the browser. So you would still need to do SDP munging until you convince the W3C to add an extra API for you for being able to set or read these parameters from the SDP, basically.
Yeah, thank you so much for the feedback. Yeah, we are very clearly aware of this, and to start the collaboration with W3C, we at least need this initial standard to start with.
Harold?
Harald Alvestrand. I do believe that we have all the API we need because the browser exposes the list of implemented codecs in the API for setting which codec you prefer to use. I'm not sure, 100% sure that you can get the implemented but not default codecs. I will have to check that. But as long as the browser implements it, you can select it, and from the information in the that you get from that API, you should also be able to read the FNTP if needed.
Yeah, Harold, I agree. There is an implementation, but like I said, there is some APIs remove the multi-opus string, so we should have some additional work.
Altanai is next.
Yeah, hi. Cisco Meraki Altanai. So what happens when a endpoint offers multi-opus to a legacy, RFC 7585 only endpoint?
Oh, yeah, that's a great question. I didn't make it explicitly on this slide, but by the proposal, I offer that the fallback. Oh, there is a second bullet on operand answer procedure. Answer must be like fallback to stereo.
Okay.
So it should be treated like any other unknown codec. You just ignore it.
Yep.
Okay. And if the, like say a B2BA middle box strips this multi-opus because of unrecognized, it may treat it as a thread, then also this will happen, right?
Yes.
Okay. All right. Thank you.
Jean-Marc?
Jean-Marc Renin, Google. Please correct me if I'm wrong here, but I got the impression that your draft only covers the so-called family 1 in terms of multi-stream opus, right? From the OGG RFC.
I'm to be honest, I think I'm not an expert on opus multi-stream codec, but what we are proposing is the most of the packetization and depacketization has been already implemented by the browser.
No, but what I mean is, so if you go in this in the OG mapping for Opus, which has sort of been copied for everything else, and I
Yeah.
think it makes sense to follow that.
Mhm.
But it defines these different families. So family one is surround, which is what you're covering, but it also has, family two where it says, okay, this is ambisonics, family three, which is another ambisonics mapping, and 256, which just says like, sorry, 255, which says this is custom. So I think it would make sense for this draft to sort of follow and try to be general enough to cover everything in there, or at least families 1, 2, and 255. I think we can have a discussion about what to do about the projection ambisonics, which is family 3, which has also sort of a matrix that needs to be in the header, or in this case, I don't know if we can have this matrix in SDP.
Okay.
But for the other ones, I think it would make sense to cover that. So at the very least, adding like a family parameter that would already get a lot of the work done, and we can discuss what to do about 3. But essentially, like if we're going to do this work, it would be good to sort of align and have this draft sort of follow everything, so that when new multi-stream Opus definitions get added, we get it for files and for RTP at the same time. So that was my first comment. The second one, the RTP draft actually has a whole bunch of parameters that it defines, P time and, things about bandwidth and all that. So probably it would be good to carry that over, or just like reference that, so that essentially everything that is included in the original RTP payload format also applies to this, unless it explicitly does not apply. Like, for example, there's stuff about mono and stereo. Maybe we don't want that, but
Okay.
Otherwise, it seems like everything should apply, even like security, like all of this.
Okay. Yeah, thanks for the great feedback. I will follow up.
Yeah, thanks.
Tim?
Oh, I think Jean-Marc covered most of what I wanted to say, but I did have one question on actually about the last bullet on the slide. The down conversion should not occur silently. I didn't understand what you're trying to prevent there. Maybe you could say a little bit more.
Yeah, sure. This proposal is to provide the surround sound as a higher priority than down conversion to stereo or other type of audio. So when there is a multi-opus, then we would like to have multi-opus as a better priority, more chance.
Okay, so you're basically just saying that you should prefer multi-opus if you
Yes,
can actually use it. Okay.
Yes.
Yeah, there might be a better way to phrase that makes that
Okay.
clearer. But yeah, understood now. Thank you.
Yeah, sure.
Okay, Jonathan Lennox speaking as an individual. I think one thing you need to say explicitly, I don't think it'll be long, but just explicitly say what you're putting on in the RTP payload format, which is probably just take the RTP, take the Opus frame, but there should be language in the Opus payload draft that you could more or less just copy. Though the one thing you do need to say is, I think if you've negotiated that you're sending, N channels, you need to actually send N channels. And if somebody sends you something that doesn't have N channels, it's an error, and just do what you want. But don't. It's not basically. It's not like Opus, classic Opus, where you can send either stereo or mono as you like, and the receiver is supposed to just deal with it. This, you're expected to send a number of channels that you've negotiated. But and other than that, I think just say it's the Opus frame with nothing fancy around it.
Okay, thanks.
Yep. All right, Marius.
Yeah, as a chair, are you seeking adoption for this right now, or do you still want to iterate a bit on your own?
Yeah, I think I got really great feedback at this time. So yeah, I will draft a little more revision. and
All
get
right,
the more
sounds good.
feedback. Thanks.
Great. All right. I think I think we're good with that. Yep. So let's go on to our last, which is Gurketch. Do you want me to drive the slides or do you want to use the clicker?
I can use the clicker.
Okay. Pass slides to the clicker. You should have slide control on the clicker now.
Great, thank you. Hello, everyone. I'm Gurtej from Apple. And I and Sridhar recently joined Eric as co-authors on the draft for RTP frame acknowledgement. Just to give some background, this provides a mechanism for the senders to know when a frame has been decoded on the receiver end. It introduces an RTP header extension through which the sender can request feedback for the frames and an RTCP message in the reverse direction so that the receivers can inform the senders about the frame being decoded. The most important use case for this that we are tracking is building long-term reference frames. This is a mechanism that exists, but there are several proprietary solutions, and we're trying to standardize that. So just wanted to provide a quick update on the status of the draft. We have about 8 open issues. And the current topics that we are discussing are around increasing the length of the frame ID field and adding an explicit recovery request. I'll go over it in the next couple of slides. So as is defined in the draft right now, the frame ID field is defined to be just 8 bits. Initially, it was thought that it would be sufficient because the encoders only allow a certain number of reference buffers. So you won't ever have that many reference buffers. But we looked at an alternate situation where you have a high frame rate application. Say you have an application which is running at 240 FPS. And the encoder is not really waiting to generate new reference frames, waiting for feedback from previous frames to generate new reference frames, and instead it just keeps moving on. It prioritizes latency, and always wants the latest reference frame to be available on the receiver side. And in this case, if the receiver has encounters a long latency spike where frames arrive in a burst, it is possible that the receiver will acknowledge a frame after a wraparound, and then when the acknowledgement actually arrives on the receiver, on the sender, you don't know whether it was for the latest frame or the one from the previous cycle which had the same frame ID. So just to keep things simple, we are increasing the frame ID field to 2 bytes, 16 bits. And the other one, again, to implement a long-term reference kind of scheme, assuming that the senders are not going to wait for all feedbacks to come in before they encode new frames. We were looking for a signal from the receiver to the sender indicating that, there has been a loss event, or I'm not able to decode anymore, and I want you to generate a new frame which is based on a known reference frame. We looked at what mechanisms exist today. So there's packet loss feedback like NACs. These are complex because they are implemented at the packet level, and then we would have to kind of map them back to the frame level. And even then, it does not tell us whether the frame was decoded. It just tells us the packets were received. The other one we have is PLI. In practical applications, is just implemented as a keyframe request right now. So what we are proposing is adding a flag to the RTCP feedback message in the reverse direction, which says, "Hey, I'm unable to decode. There's either a loss event, and this is the last frame that I've received, which you had marked with a frame ID. So please generate a new frame for me based on this." So it's a receiver triggered request to recover decode. And that's all I had. This is a quick update. The next steps, we are going to try to close out the remaining GitHub issues. We welcome any feedback on the draft. Please provide your thoughts on GitHub. At this point, we're not requesting adoption. We still want to iterate more on the draft before we do that. But I think we are kind of moving in the right direction. Thank you. Happy to take any questions.
All right, I think there's no questions. And all right, Harold, did you?
Might as well ask, are you seeking adoption?
No.
He said not at this time. Yeah.
Okay, coming later.
But still would like your feedback on the draft.
Absolutely. I mean, my principal feedback is that I like it.
Great, thank you.
So, I mean, I know Apple doesn't announce anything, but is your goal to put this into Safari's WebRTC or some other?
Not in the we will have an implementation.
Okay.
Yeah.
All right. All right. In that case, thank you. I mean, you can keep us up to date and let us know if and when you want to do the adoption.
Okay, sounds good. Thank you.
Okay. All right.
Jonathan, you come in very low.
Oh, sorry. Yeah, I keep not bringing the mic close enough. Yes, I was just thanking the speaker and saying, let us know when when they wanted us to consider adoption, and let us know how it goes. So I think that was everything, unless I've missed something. Does anybody have any other business? Otherwise, thank you all for coming to our AVTCORE session. What are our I think as I recall, our chair action items are to Mario.
So I recorded them, and my notes say plan interim meeting. Sometimes around January. Probably send out a survey soon to find a good date. We still have to do a call for adoption for the APV payload. We didn't talk about it this time, but at the last IETF, and we didn't find the time to do a call for adoption, so we have to do that. The working group last call for JPEG XS, as discussed today, and a call for adoption for the avatar representation.
All right, sounds good. Thank you all. And we will see you
all for this meeting.
At our interim in January.
Thank you very much. Yep.
Bye-bye.
Have a nice remaining IETF week.